Hello everyone. We are in Unit 3, Lesson 4. We're talking about linear modeling. In the Common Core Algebra 1, you started using linear modeling to model any process that had a constant rate at which one variable changes with respect to another. This is all up at the top here, a constant slope. So we'll review some facets of this type of modeling and what we will draw from it. So in exercise 1, Dia was driving away from New York City at a constant speed of 58 miles per hour. He started 45 miles away. So a constant speed, 48 miles an hour. Pick out the key words or phrase. Oh, and yeah, we're going to have a little note quiz. Someone was asking me about a note quiz, so I guess I'll give you one on Wednesday. So make sure you keep track of what's going on in your notes. All right, so we want to write a linear function that gives Dia's distance D from New York City as a function of the number of hours H he has been driving. So the key thing here is it's not always X's and Y's. So if they tell you specific variables to use, you have to use the variables they give you. So the distance D, capital D, as a function of the number of hours he has been driving. So he goes 58 miles per hour. So it would be 58 times the number of hours. And he has already started, because we're looking for the distance D from New York City, and he already started 45 miles away. So the slope is 58, the y-intercept is 45. So if Dia's destination, part B, is 270 miles away from New York City, algebraically determine to the nearest tenth of an hour how long it will take Dia to reach the destination. So what we want is we want to be the distance of 270 miles, and we have to figure out how many hours it is going to take Dia to be 270 miles from New York City. So using your basic algebra to solve, bring the 45 over. So then we have 225 equals 58H. Divide by 58, throw it right in your calculator, and we will have H equals 3.9 hours. We don't have to put another H there, okay, because H is the number of hours. So there it is, and make sure you do read and make it to the nearest tenth of an hour. Be very careful of that. Yes, this is a linear model because it's going up by the same slope. In exercise 2, Edelyn is trying to model her cell phone plan. She knows it has a fixed cost per month along with a $15 charge per call. So last month, Bill, she was charged $12.80 and she made 52 calls. So what we want to do is we want to create a linear model point slope form. I don't know what happened there. In point slope form. So in order for it to be in point slope form, I need an X, a Y, and a slope. So Adeline must pay P, and the given number of phone calls she makes is C. So be very careful of this. Number of phone calls she makes, C, is going to represent your X. So it's going to be C and P. So the P representing how much she must pay. So when you go back and look at the information that they gave you, she was charged $12.80 for making 52 calls. So the C is 52 and the P is $12.80. And then therefore the 0.15 is your slope. So what we have here, instead of Y, we're using P. So we have P minus. So it's Y minus Y1. So P minus 1280 equals M, and then that's a 15.15, and then it's X, which is the C, minus 52. Okay? So I hope you're able to see that. I'll draw a line. So right there. This is the equation in point slope form. Okay? Let's do another break here. Okay, now, how much is Adelyn's fixed cost? In other words, how much would she have to pay for making 0 phone calls? So if I'm making 0 phone calls, that means my C equals 0. and this is going to be my y-intercept, is what I'm looking for. So in order to find the y-intercept, I have to go back to my point slope form of a line and put it into slope-intercept form. So this 0.15 has to be distributed to both terms. So I have P minus 1280 equals 0.15 C minus 780. I couldn't squeeze that 0 in. Okay? So that's when I distributed the 0.15 through. And then, I mean, you don't have to, but to get the P by itself, you add the 1280. Oh, yes, you do. I'm sorry. I'm thinking of the slope. Add the 1280. Okay? So you have P equals 0.15 C plus 5, which represents $5. So our fixed cost is $5. So that's how much it would cost in order for her to make 0 phone calls. Okay? So that's your equation. Put in the 0 in for C, and the y-intercept is 5. Now in the next one, we're going to put on graphs. So I already took the time and plugged it into my calculator. So if you need to plug it into your calculator, you might have to pause this to plug it in. So in exercise 3, we're talking about widgets. So what they are, those are just, like it says right here, generic objects of no particular use. So the cost, C, in dollars to produce W widgets is given by the equation. So again, they're not using the X and Y, they're using C and W. So there's your first cost equation. So it's 0.18W plus 20.64. And then the widget sells for 26 cents. Thus the revenue, so there's your revenue R, is 0.26W. So that's the revenue is what you bring in for selling your widgets. So using your graphing calculator to sketch and label each of these linear functions for the intervals 0 to 500. Okay? So we want to make sure that we do label our y-axis with its scale. Now, we have to be very careful here. When I put it in the calculator, okay, I put it in the calculator, and it was the first one I put in. So you can see one of the graphs. You can't see both of them. So remember what we have to do here is we're going to have to zoom out. So we go 4, and we're going to 4 zoom out again, and of the center. So I just did over here because I know everything's in quadrant 1. So we keep zooming out. See the x-axis going up? There it is, up to 425. So this gives me a good idea of what's going on right here. Okay. Now, if you would rather use your such that when you're finding the highest and lowest values, that is very strongly recommended. Because we have to go all the way up to 500. We are not going to go. Well, I don't recommend going to Control T and scrolling down to 500. Okay, it's going to take you quite a little bit of time here. So the only thing we can find here of relevance to this original graph is the y-intercept. You see my first graph is 0, 20.64, and my second one is 0, 0, okay, because it's just 0.26 x right up here. Oh, and the other thing I have to point out is that, yes, they use W in the example, but when you graph it, you have to use X. So we're going to go here. So I took the liberty of putting in the two equations, the 0.18x plus 20.64, such that x equals 500, because we are going from 0 to 500. And I also did the 0.26x where x equals 500 and saw that I have 130. So what you have is you have the starting point and ending point. So when we're going from 0 to 500, you can put a couple more points in, but as long as you have the beginning and ending point and they are correct, then you have no worries when you graph it. So we go back here, and the first one, the top one here, the 0.18W plus 20.64. Okay, so that had a starting point of 20.64 and an ending point of 110.64. When I did R as 0.26W, had a starting point of 0 and an ending point of 130. So I'm going to label this one. Why don't we label this like 1? You can label it 130 if you want. 130, 140, 150, anything at all. So what we have is so 130. So this is about halfway, about 65. So then about a third of the way down, right about here, this gives me my 20.64. Okay, so that's 20.64 because that's where that first one starts. That's the C one. Okay, so 20.64, and it's about 110. So I'm going to label this one here 2. We'll label this 500. That's the highest. So I'm going to go 20.64 to about 110. So what did I say? This was maybe right about there. Oh, I'm in the way. Okay, so right about here. So I'm going to say from here is my starting point to about there. Okay, and again, it's a rough sketch. Okay, and then I'm going to put a line in. So here's the line like that. Okay, so that's the first one. And because there are 2 graphs, you're going to want to label both of them. So I can't fit it in here, but you put C equals and you put the whole equation in. I can't fit it in, but you should have it in your notes. Remember, I'm giving you a note quiz, so make sure they are complete. So put the entire equation in here. C equals 0.18W plus 20.64. Oh, my lights just went out. All right, so the next one starts at 0. Okay, so we start at 0, and it goes up to 130, so approximately here. Okay, and then, with your straight edge, of course, we go ahead and we connect them like that. Okay, let me pause this. Okay, I had to get my lights back on so I can see what the heck I'm doing. So there's my second graph, and this we label with an R equals 0.26W. So remember, anytime you have multiple graphs, you have to label the lines, the parabolas, whatever they are. So it says, using your graphing calculator, sketch the label the linear functions, got it, from 0 to 500. Label your y-axis, got it. Okay, using your intersect command to determine the number of widgets that must be produced for the revenue to equal the cost. So what are we looking for? Right here. We are looking for the intersection point. So we go to the intersection point and go to your graph. Where are you? Right here. Go up. Control up. Come on, buddy. Oh, I don't want to do that. I think I need to go here. Now go control up. And here we are. All right, so we need to get rid of this table. Remove table. I was on it. Okay, so remember, menu, analyze graph, intersection, lower bound, upper bound. What is it? 258.67.1. So this point is 258.67.1. That's the intersection point. The number of widgets is an X. So determine the number of widgets that must be produced for the revenue to equal the cost. So we need to produce 258 widgets. Okay. If the profit is defined as revenue minus the cost, create an equation in terms of W for the profit. All right. So my profit is the revenue. So 0.26W minus the cost, which is, this goes in parentheses, 0.18W plus 20.64. Okay. Because revenue minus the cost will give you your profit. Distribute that negative, combine the W's, I end up with profit. Oh, put a P up here. Profit equals 0.08W. Oh, I'm almost out of time. Minus 20.64. Okay. So why don't you try this last one, D? Why don't you try to put this on your grid? I'll make sure that I show it to you in class on Wednesday. All right. Boy, that really flew. It didn't seem like it went that fast, but it did. All right. I'll see you in class. So remember, have everything in your notes complete. Note quiz. Okay. Bye now.